So let's finish, and then I will tell you what Chris is talking about. Because I do understand his point. He has a good point. Integral of u to the 5 is u to the 6 over 6 with 1/2 standing in front of it. This part will be on the quiz today. You should know how to integrate polynomials.
Actually, this comes to the exact same conclusion I did. So.
Plus c as a constant. But then remember, this is the answer, but nobody knows what u is. You are the only one who knows what u is. You use it to help yourself to figure out the integration. So you have to go back. Don't forget. Let's use blue color. Go back to x notation. How to go back to x notation? Use equation number 1. I will remind myself that u is actually 2x plus 1. So instead of u to the 6 over 6, I will have 1/2, and then I will have 2x plus 1 to the 6 over 6 plus c. Collect the constants if you want. 1 over 12. 2x plus 1 to the 6 plus c. And this is the answer. And then I will tell you how to do it faster. That's what I call shortcuts. U-substitution is better than shortcuts though, because it always works for very hard cases.
None of this made any sense to me.
It will click with time. Questions? Anyone else? Yes. Yeah.
How did it go from 2x plus 1 to 2x minus 1?
Oh, sorry, that was a typo. Good point. Good catch. Good job. Plug it exactly as it is. So if it was this one, you plug it in back. Anyone else? What do you think? Questions? U-substitution. We taking something from inside, call it u, reconstruct the whole integral. So it's all in terms of u. That should be easier to integrate. Finish integration. Go back to the original notation. Sometimes you can do it without U-substitution, and this is what I call U-substitution shortcuts. In this case, it was this shortcut over here. Integral of ax plus b to the n is actually just a power rule. You raised to the n plus 1, divide by the n plus 1, and then you also divide by the leading coefficient. This is why you put it in purple, by a. This is a shortcut, which is still U-substitution in the core. It's just shortcut of U-substitution. Same with cosine and sine. You have it today in your quiz that you will have cosine of 5x. How to integrate cosine of 5x? It will be sine of 5x divided by 5. And so on. E to the ax plus b is e to the ax plus b divided by this leading coefficient. So those are shortcuts of U-substitution. We just never told you that in this class.
Can I write down the shortcuts?
Yes. You can write this down. But we have most of this. You guys can write it down. And then I will do one more example to prove, Chris, that sometimes these shortcuts don't work. And that's why we need to use U-substitution in general.
Mainly, I just didn't understand any of what was being done in the first problem.
Yeah, and I'll show you one more, and one more, and then one more, and then one more, and one more, and it will click. It just takes practice to click it, yes.
What if it was 5x squared?
Good point. It only works for linear functions. If you have squared inside, you have to do one more U-substitution inside of that U-substitution. Yeah, exactly. It works only for linear functions. The shortcut, I mean. U-substitution works for other cases, though. That's why we teach. So, yeah, I can give you these notes actually. And there's my YouTube video on this shortcuts is really good. I give it to all calculus classes. Somehow instructors do not teach those shortcuts, so I teach them, and then it's faster to work on the test, which is good.
Don't we just divide by the derivative of whatever it is?
Not necessary all the time, and I'll show you right now why. One more example tells you that it's not that simple. Integral of 2x. Let me see if I want to make it even harder. 2x. Let's do 4x. Then it will be even harder. 4x sine of x squared minus 4 dx. So this one doesn't fit any shortcut. How do I know that I should use U-substitution? I will write down the formula soon for you, but there is no particular formula. The intuition tells you that if we're doing chain rule is a derivative of our outside times the derivative of the function inside. So to undo derivative, we kind of should recognize that one piece in the integral is derivative of another piece, or so. So first of all, I'm looking like, okay, 4x kind of have connection with x squared minus 4, right? If you differentiate x squared minus 4, you get 2x, which is pretty close to 4x, so that might work. And by my work, I mean we're finally entering a situation when you try and fail, and it works. So I was doing this without computers or internet. And that's exactly, my notes were 5 pages long because I would try. Finally, I'll go call my friend with this wired phone in the wall and like, did you get this problem number 17? And then we'll figure out, and then it works. So U-substitution and the topic on Monday are like these. You have to keep trying and don't get too frustrated that it's so long. So one intuition is that this part over here for x looks like a derivative of this part. And the other one, I don't like that sine has something inside and it's complicated. That's also good intuition to just call this u and see what's going to happen. Because sine of u is easier than sine of x squared minus 4. U substitution makes your life easier. So they're supposed to give you the first hint what to call u. Let's do it. Let u be x squared minus 4. The moment you found u, immediately differentiate it because we have to change dx into du somehow. Then du is, I don't even write then anymore. That's just a table. U is x squared minus 4. Du is 2x. And then don't forget to put dx. That's exactly why you're putting there, because you need it. You need to find it. You need to solve for dx. Some students don't solve it, and I'll show you on Friday why. Dx then is divide by 2x. Divide by 2x. You divide it in your notes. I want to make clean notes like so. It will be du over 2x. You have 3 equations. Use equation number 1 and number 2 to fix everything in your integral. I will plug u inside of the sign, and I will plug dx as well, and see what is going to happen. So I'm rebuilding or reconstructing my integral. Integral is, there's still 4x in front, which will conveniently cancel out, and it's not by coincidence, because we recognize that one piece there is a derivative of another piece. So when I took derivative of x, when I took derivative of u, the choice was so good that now it will cancel out. When I plug in du, and I'm dividing by 2x from the formula, which will cancel out with 4x. So cancel, 2 still stays. The integral will be, I will kick out 2 outside. I always kick constants outside. It will be sine u du. This was the most important part. We're going to finish in a second, but the example. But this, I want to ask, what do you think about this?
Okay, now it's getting something vaguely than
The step of the building U-substitution, it's like you using some kind of tool to temporarily make your integral easier. You finish integrating and plug back the original stuff. That is the idea. The complicated stuff to comprehend is when you choose another variable, you have to find the derivative of that to change into dx. So that's why there are 3 different equations. What is the integral of sine? Minus cosine. Don't forget, it's minus cosine u. Some people don't even write u anymore. They plug your u back right away, which is x squared minus 4. I will do it starting later, but for now, to have good notes, I'll put that it is minus cosine u plus c. Don't forget the plus c. Finally, I'm reminding myself that u is x squared minus 4. I need to go back because nobody knows except you what u is. When you present it at the lab or internship you have, you say, oh, the answer is minus 2 cosine u. They'll be like, wait a second, our bacteria are measured in x. What the heck the u is? So that is wrong. It's your mistake. You should represent the answer in terms of what people started with, not whatever you're doing intermediately. Your u is x squared minus 4, which is a quadratic function inside of the cosine now. X squared minus 4 plus c. So you can now say that the result of the integration, which for example is the area of the bacteria growth of the 4x sine x squared minus 4, is this function. Now it's a cosine with still quadratic function inside, but multiplied by minus 2. Yes?
Where does like the du go? Or like,
so that's a good question. There are 2 ways of teaching it, and that's not the way I like what we're doing right now, but I want to follow the notes. And on Friday, I will tell you how I see it. du came from differentiating u, right? So,
but I meant like down.
yeah.
Oh, okay.
Oh, you mean here.
Yeah.
This one is when you integrate, integral sign disappears and this thing disappears. So finishing integration means these two parts disappear. These two parts means integrating. Just like with derivative, prime disappears when you differentiate it. Oh, that's a good question, yeah. More questions? What do you think? You can always check yourself. And that's the last thing we do. And let's do the quiz. Let's check by differentiating the answer. Oh, I should have asked you. How should we check? We want to differentiate the answer, and whatever we're gonna get should be whatever we had inside of the integral. So I put huge prime over here. And now you will see that we're gonna do chain rule. Minus 2 stays. Derivative of cosine is minus sine. Copy the part inside, that's chain rule. But then times, chain rule starts. Derivative of the function inside. The function inside is x squared minus 4. Derivative of that is 2x. Derivative of plus c is 0. Simplify. Minus 2 minus 2 times minus 2 is 4. X can be kicked out outside. Sine of x squared minus 4. Check. This is the same thing we had inside of the integral, so we did it correctly. Whatever was inside of the integral was exactly this function. So today on the quiz, you can check yourself by differentiating. And on a test, you can check yourself by differentiating the result. And that's why students like integration, because you can see if you messed up by taking a derivative. Just make sure you remember, derivative of sine is cosine, so when you integrate, it will be plus. Derivative of cosine is minus sine, so when you integrate, it should be minus. Questions? Then let's do the quiz. We're gonna do more examples on Friday.